All right, guys, this is just going to be me doing a few examples of how to find magnitudes and arguments of complex numbers. So first thing you should do if I'm asking you this question, it's like, here's z, find its magnitude, find its argument. Remember, this is the distance from the origin to the point that this thing is going to occupy in the complex plane. This is the angle that it makes with the x-axis. So this goes 4 over and -3 down. So this is z here, 4 minus 3i. So remember, the magnitude of z is, I'm going to write it down here, magnitude of z is square root of a squared plus b squared. In this case, a is 4, b is -3. So I get square root of 4 squared is 16, -3 squared is 9, square root of 25 is 5. Magnitude is 5. Now the argument's going to be a little trickier, but we saw previously that it's the inverse tangent of b over a. In this case, is the inverse tangent of -3/4, which is, get out the trusty calculator. Make sure it's in degree mode. Inverse tangent of -3/4 is, it says -36 we'll say 87. We'll say -36.9. That's fine. Just the nearest 10th from now. Nope. That's not close enough. -36.9 degrees, which means basically like this is -36.9 degrees. Like this, it's like negative because it's going clockwise. So that's the argument. We're generally going to want to measure the angle going this way. This is like the positive direction to measure angle. So like, while this is -36.9, I want to know this one. This is theta. And if you think about it, if you add up these two angles, you have to get 360, which means that whatever this one is, the 36.9, 360 minus this is going to give me this bigger one. So I do 360 minus that angle, and I get 360 minus that angle, and I get 323.1. So I don't know, honestly, I can't remember if we learned this or not. So I'm just going to tell you again. When I measure these arguments, these thetas in the coordinate plane, I always want to measure them going this way. This is like the positive direction for angle. You start at the positive x-axis and you go counterclockwise. So this is how we should be measuring. If I get this -36.9, it's telling me that it's going this way, which means I got to do all the way around the other way. So -3 minus I, wait, what's the last one? Oh, -3 minus I is down here. Say -3 minus I, go back 3, I go down 1, and this is here's my z right there. So the magnitude again, square root of a squared plus b squared. A is -3, b is -1. So z is a square root of 9 plus 1, which is a square root of 10. That was pretty easy. Argument's a tricky one. So I do inverse tangent of b over a is going to be the inverse tangent of 1/3, which is 18.4. So you're like, well, I'm trying to find this angle. So like, this angle is clearly bigger than 18.4. It's bigger than 180. So like, which angle is 18.4 in this picture? And you look at this and you might be able to guess it's this one. It's this little fellow here. This one right here is the 18.4. So to get this whole angle, I'm like, well, it's like 90 degrees, 180 degrees, and then add 18.4 degrees. and you get 198.4, right? That's the argument. So we're going to see, I'm going to do 2 more examples, but there's like, we'll have to figure out what we, as a class, we decide is the best way to indicate what these angles are, but I think this is a pretty good way to do it. Just kind of draw the thing and see where the angles appear and then add or subtract as necessary. All right, z equals 5. That's like 5 plus 0i. So a is 5 and b is 0. This is what I would call a real number because there's no I part, which means you just go over 5 to the right and that's it. There's no up or down. This is the point 5 plus 0i. So the magnitude, you could do the square root of 5 squared plus 0 squared, but you can just look at it. How far is this distance here? It's 5. You go over 5. That's it. Magnitude is 5. The argument, like how much do I rotate from the positive x-axis to get here? I don't rotate at all. The argument is 0 degrees or 0 radians. And not surprised, this one is 6i. This is like 0 plus 6i. So again, a is 0, b is 6. So I go over, I go left and right none, and I go up 6 to 6i. Again, you can still do the same trick for magnitude where you're like the square root of a squared plus b squared. But like, how far is it from here to here? Well, you go up 6, so 6. And the argument of this is like from the positive x-axis counterclockwise, this is 90 degrees. And the problem with this one is you can't do the inverse tangent trick. If you try to do theta, get the inverse tangent of 6 over 0, and like this is no good. So like you kind of, for the ones that are just purely imaginary, the tangents don't exist, so you're going to have to just look at it and see where it is. If it was like down here, which was negative 6i, the argument would be 90, 180, 270. Okay, that's not what we had, but if we did, again, this inverse tangent trick's not going to work for a purely imaginary number. So we'll do some more graphing problems because these ones where you have to figure out what the argument is and it's not the answer you get on your calculator are a little bit tricky. So I'll put together some more practice with those and we'll do them in class. So hope you learned something.